watching this right now, pause for a moment and imagine standing alone in the frozen darkness, breath turning to fog, when the heavens suddenly ignite. An object screaming overhead at tens of thousands of miles per hour, glowing white-hot, shedding fire like a dying star. No warning, no sirens, no explanation, just the quiet certainty that whatever it is, it wasn't supposed to be there. Stay with this story until the end, because what fell from the sky that night wasn't a meteor, wasn't a weapon fired in anger, and wasn't an accident anyone was prepared to explain. It was a Soviet satellite carrying a secret so dangerous that even the superpowers struggled to control the aftermath. And by the time the truth became public, it had already scattered radioactive debris across an entire continent. Before we begin, if stories about Cold War secrets, near catastrophes, and moments when history almost took a very different turn keep you watching until the last second, make sure you're subscribed. These are the kinds of stories that don't just inform you, they stay with you. The night begins far from cities, in the deep silence of Canada's Northwest Territories. January 24th, 1978. Temperatures hover well below freezing. The land is vast, empty, and unforgiving. Most people are asleep. A few are awake by necessity. Truck drivers on long hauls, pilots watching quiet radar screens, hunters checking traps. None of them is thinking about space. High above Earth, nearly 1,000 kilometers overhead, a Soviet satellite called Kosmos 954 is already dying. Kosmos 954 was never meant to be noticed. It wasn't a communications satellite or a weather observer. It was part of a secretive Soviet program designed to hunt American submarines, nuclear submarines hiding beneath the oceans, carrying missiles capable of ending the world in minutes. To do that, the satellite needed immense power, more power than solar panels could provide. So Soviet engineers made a fateful decision. They put a nuclear reactor in space. The reactor was small, compact, and terrifyingly efficient. It allowed the satellite's radar to scan vast stretches of ocean, detecting the faint signatures of metal hulls beneath the waves. In theory, when the satellite reached the end of its life, the reactor would detach and boost itself into a high graveyard orbit, safely away from Earth for centuries. In theory. But by early 1978, something had gone wrong. Kosmos 954 was losing altitude. Ground controllers in the Soviet Union watched as its orbit decayed day by day. Calculations showed the unthinkable, it was coming down, and no one could be certain where. The satellite circled the planet once every 90 minutes. With each pass, its orbit dipped lower, brushing against the upper atmosphere, slowing it further. Scientists around the world began to notice. American tracking stations confirmed the data. The Canadians were alerted. Quiet conversations began between governments that rarely trusted one another. The problem wasn't just that a satellite might crash. It was what this satellite carried inside. A nuclear reactor re-entering the atmosphere could break apart, scattering radioactive material across thousands of kilometers. No one knew if it would burn up completely. No one knew how much radiation would survive, and no one knew where it would land. On January 23rd, predictions narrowed. The satellite would re-enter sometime within the next 24 hours. The potential impact zone stretched across half the globe, from Europe to Asia to North America. Millions of people slept under that invisible threat, completely unaware. Then, in the early hours of January 24th, Kosmos 954 made its final pass. Over Western Canada, the satellite hit thicker layers of atmosphere. Friction turned metal into fire. The nuclear reactor did not vaporize as hoped. Instead, the satellite broke apart violently, exploding into fragments that streaked across the sky like a celestial shotgun blast. Witnesses described the night suddenly turning to day. A massive fireball split into multiple glowing pieces, each leaving a trail of light that lingered for seconds. Some heard sonic booms. Others felt the ground tremble faintly beneath their feet. Pilots radioed in confusion. Air traffic controllers scrambled to identify the object. For a brief moment, some feared it was a missile attack. In the context of the Cold War, that fear was never far from the surface. By morning, it was clear the debris had fallen across a massive swath of northern Canada, an area roughly 600 kilometers long. Remote, yes. Sparsely populated, yes. But not empty, and the danger had only just begun. Within days, radiation alarms sounded in monitoring stations across Canada. Traces of radioactive material were detected in the snow. The Canadian government demanded answers. The Soviet Union, after initial silence, admitted what had happened. A nuclear-powered satellite had fallen from the sky. What followed was one of the largest and strangest cleanup operations in history. It was called Operation Morning Light. Teams of scientists, soldiers, and radiation specialists were flown into the frozen wilderness. They wore protective gear, carried Geiger counters, and searched mile after mile of snow-covered terrain. Helicopters skimmed low over forests and frozen lakes, scanning for radiation spikes. When the instruments screamed, crews marked the location and moved in cautiously. They found pieces of the satellite scattered like shrapnel, twisted metal, charred components, and, most alarmingly, fragments of the reactor itself. Some pieces were small enough to fit in a hand. Others were larger, partially buried in snow or ice. Many were dangerously radioactive. Every recovery was a calculated risk. Exposure times were carefully limited. Fragments were sealed in lead containers and flown out for analysis. Even so, the full extent of the contamination was impossible to know. The debris field was vast. The terrain was brutal. Winter storms erased tracks and buried evidence. For months, the search continued. Behind the scenes, diplomatic tensions simmered. Canada presented the Soviet Union with a bill for the cleanup, over $6 million. The Soviets disputed the amount, then the responsibility, then the urgency. Eventually, they paid a portion, but the incident left a lasting scar on international space policy. Kosmos 954 had proven something terrifyingly simple. Humanity had brought nuclear power into orbit without fully understanding the consequences. Years later, scientists would quietly acknowledge how close the disaster came to being far worse. Had the satellite broken up over a populated area, had the reactor scattered over farmland or cities, had weather patterns carried radioactive dust farther south, the story might have ended very differently. Even today, some fragments were never recovered. Somewhere in the northern wilderness, pieces of a Cold War satellite may still lie frozen beneath the soil, silent remnants of a night when the sky itself became a threat. The Cold War eventually ended. The Soviet Union collapsed. Technology advanced. Rules were rewritten. Nuclear reactors in space became rarer, more tightly controlled. But the lesson of that night remains. Space is not empty. It is connected to us in ways we often forget. What we launch upward can come back down. And when it does, it doesn't ask permission. So the next time you look up at a calm, star-filled sky, remember that on one winter night in 1978, the heavens burned, governments held their breath, and a nuclear machine fell to Earth. Uninvited, unstoppable, and unforgettable. If you stayed with this story until the end, thank you. Stories like this remind us how thin the line can be between routine progress and irreversible disaster. And if you want more true, cinematic stories about hidden moments in history, the ones that almost changed everything, make sure you're subscribed. Because the most dangerous stories are often the ones that almost never get told.